Hello everyone, welcome back. This is chapter 3, part 3. In this part, we are studying the time series data. We are going to talk about causation with observational data and time series data. Time series analysis is the first step. We talked about the gold standard of causation, which is randomized trials. And we talked about it in the previous part. And we also talked about why randomized trials are hard to come by or the issues with the randomized trials. Let's get started with the topic of estimating causation with the data. We actually get observational data. Observational data means this is a type of data set that's already out there, that's ready to be collected, or that's already collected, ready for researchers to analyze. Okay. Observational data is data generated from individual behavior observed in the real world. Most common data we find in doing research. So for instance, SAT score example, data on which Harvard freshmen took the coaching course and their SAT scores were provided. So it's not a random sample of students who are assigned to an SAT coaching course, but we are looking at the outcome variables. So there are four main approaches with observational data. Number one is time series analysis, which we'll be covering in this part. Cross-sectional analysis. So time series analysis looks at two different variables across time periods. They're measured and we look at the relative movement of these two variables. Usually not very good with establishing causality. The second one is cross-sectional regression analysis. Cross-sectional regression analysis entails focusing on a group of individuals. It could be a group of companies. It could be a group of, countries. And in one period of time, just focus in one period of time. We also have quasi-experiments. We're going to spend a lot of time in this. These are also called natural experiments and also structural modeling. These four different approaches that we use with the observational data. Let's talk about time series analysis. Documents the correlation between the variables of interest over time. So for instance, we could gather data over time on temporary assistance to needy families, income guarantee that we studied. This is basically government giving certain guarantee income to a single mother of 3, let's say, $10,000 a year. I'm just making up the numbers. That's actually pretty generous. Okay? And compare the labor supply of single mothers over time. So we're actually looking at the temporary assistance needy families income guarantee average, for the sample, and also labor supply of this woman over time. Okay, so here's the graph. If you look at this, we have monthly benefit guarantee for a family of 4, that is mother and 3 children. This is real in real terms. That means it's calculated in $2010. And this is shown in this green curve, monthly maximum benefit. As you can see, real benefits have been declining since late 1960s, okay? So real benefits have declined dramatically over time. Let's take a look at the other red curve. So this is hours worked per year. So this is the average hours of work per year by single mothers. So as you can see, if you look at this graph, right, maximum monthly benefit and hours worked per year, real benefits have declined dramatically over time and average hours have risen substantially. So one is going down, one is going up. Okay, apparently this supports the cutting off temporary assistance to needy families benefits should increase labor supply. Okay, so there are different time periods. Of course, you will see some. Let's take a look. There are some time periods you will see some irregularities. For instance, here Benefits are declining. Oh, hours are declining as well. Going to grab a highlighter. Here, benefits are declining. Hours are going up. Okay, this consistent. In this time period, you have hours going up, benefits declining. Okay. And in this time period after 2000, you see hours declining, benefits also declining. So it's little hard to look at this picture and say, oh, there's a negative relationship, because in sub time periods you will see different relationships. So many other potential explanations for the changes, such as maybe there's greater acceptance of women in workplace. That's why the labor supply of women has been increasing. Look at this red curve. It's been going up. Maybe there are better childcare options. Maybe there's been changes in the social norms about working. It's more accepted now for women to work. Other government programs like earned income tax credit could be introduced at any time. Maybe economic growth is causing this increase in labor supply of women. So you can't just say, look at this correlation and say there's causation. So this is something you need to remember. In many cases, time series analysis is not useful for causality. Okay? It is useful if there are sharp changes in policy variable over time. There may be some room for valid inference in this case. So, for instance, let's take a look at this story. So, in the US, right, smoking has been going down. The most important smoking is the youth smoking. What is youth smoking? Smoking is the youth smoking percentage is the percentage of high school seniors who smoke at least once a month. Okay? So let me tell you this, sharp changes in policy example in terms of tobacco smoking and the price of cigarettes. In April of 1993, there was a price war in cigarettes. So cigarette companies dropped the price of cigarettes from $1.29 to $1.18. Cigarettes are getting cheaper in real dollars. So this price sharp decline, let's see if it caused an increase in youth smoking. Tobacco settlement of 1998 is when these tobacco companies faced with very large lawsuits from smokers. Cigarettes causing cancers came out during this time. People started suing because they weren't being warned. Let me tell you something. Before 1994, in the United States, you could smoke indoors. And how do I know this? I went to UT Austin, University of Texas at Austin, to get my PhD. And in those doors, it used to say, as of 1994, you cannot smoke indoors. Oh my gosh. So 1994, you couldn't smoke indoors. And then tobacco turned out to be, they said, oh, we didn't know. Tobacco causes cancer. So let's take a look at these two sharp policy changes. Let's see. This green line is the real price of cigarettes per pack in 2015 dollars. Okay? So as I said, in 1993, there was a cigarette price war. Price of cigarettes went down. Okay? Sharp decline. April 1993. Youth smoking rate. What is youth smoking rate? Percentage of high school students who smoked at least once a month. Okay? So as you can see in this sharp decline of prices, youth smoking rate is going up. This red curve is the youth smoking rate. This green curve is the real price. And here's when this tobacco company settlements happen. Because tobacco companies are settling big lawsuits, price of cigarettes shot up. Went up. And look what happens to youth smoking rate. Youth smoking rate declines. So if you can find these sharp policy changes, you can use what we learned about difference in differences estimation. I will see you in part 4, where we'll talk about cross-sectional regression analysis. I'll see you then. Bye.